Hello everyone and welcome back to my YouTube channel. Welcome to the series of building end-to-end RAG application. So this is the part 3 of this series, and in the previous two parts we have covered the demonstration of the application in part 1, and in part 2 we have covered the physical and logical architecture and the basic overall project flow. Now if you have missed those two videos, I would highly recommend go ahead and check out those because those are very important, and as per our goal we are targeting to complete this end-to-end project. So we have started from very scratch, defining the problem statement, understanding the business requirement. Then accordingly, we have built the physical and logical architecture of this particular project. Now in this particular video, we are going to focus on coding this particular application, as well as we will be creating the cloud resources as and when required. So this is going to be again really interesting video. So please watch this particular video till the end. And if you have any questions, please feel free to drop them into the comment section below. So let's get started and let's straight jump onto the VS Code. Okay, so you will get the link of this particular code in the description below. So I have pushed this particular code to the repository along with the nodes. So you will get all the details, and I will keep updating this particular repository. So by end of this particular series, you will get everything that is required. And feel free to use this particular project into your resume. You can definitely explain this into your resume. And trust me guys, if you explain these kind of projects, because whatever we are covering, right, it is completely relevant to the industry. Like whatever we build in the real organizations, it's completely in line with that. So feel free to mention these projects into your resume. So let's get started, and you will get the codes and everything so that you can do the hands-on later on. Okay, so if you are not willing to code along with me, that's fine. You can sit back and relax and watch this particular video. But yeah, I would highly recommend pause this video, or while doing this, while watching this particular video, go ahead and practice this stuff, because once you practice, then only you will be able to understand this particular project flow. Okay, so again, in the era of AI assistants, we are not going to code this particular project line by line. So instead, what we'll be doing is we will, based on the flow that we have defined in the architecture. So this is our logical architecture and the physical architecture. So based on this particular flow, we are going to code this particular application. So let's get started. So the first step is report ingestion, and in that report ingestion, the first step is converting from PDF to Markdown. Now PDF to Markdown meaning we have the data set. So if you expand the data sections, we have raw PDFs. So let me quickly show you one of the PDF. Okay, so if you see, this is a organization data, which is the annual report of Apple company. Now below, if you see, we have lot many details like the business related information, risk factor, then we have tax informations, the total sales and everything. So if you scroll down, you will get all those information. So if you see, we have total purchase information, then we have some trends, and again we have total net sales and all other information. So as part of this application, we need to extract these details and we need to show these details onto the dashboard, user interface dashboard. Like we need to show some KPIs like total revenue, then the cost, how many, what is the profit of the organizations, and all those details. Based on that, the investors will take a decision whether to invest into this organization or not. So yeah, this, all those things I have already explained in previous two videos. So if you have missed that, please go ahead and check out it. Now, coming back to the project, so I have maintained this particular file, project journey.markdown. In case you face any issues, you can refer to this file. Along with that, I am also adding the README. I am yet to add the instructions into the README, but I will add all the detailed instructions, what and all steps that you need to follow, what parameters that you need to set so that you can run this particular project in your local. And if you face any issues while executing this, please reach out to me and I'll definitely help you. Now, as this is the AI powered investor intelligence platform. So first step is we need to convert these annual reports into the Markdown. And I already mentioned why we need to convert this to the Markdown, because Markdown preserves the structural information available in the PDFs, like the table structures and other information. Now, for that, we have a folder called ingestion. So under ingestion, you will get the PY file, PDF to Markdown conversion .py. Now here, if you see, first of all, we have used this particular library PyMe PDF for LLM. Now why PyMe PDF for LLM and why not normal PyMe PDF? Though our documents are digital documents, digital means we can directly extract the text. It is not the scanned copies, but in order to convert to the markdown, we are using this PyMe PDF for LLM because it helps maintain the structure of the data. Like we have the sales information available in the table. So whenever we will convert this file into the markdown, it will make sure to maintain that structure as is. So we will execute this code. So first of all, let me delete whatever is there in the markdown. So let's go ahead and delete it so that we'll be able to see this. Now, first thing is we need to create the virtual environment. That's the first step of every application. So let's, in the terminal, yeah, we'll be using UV as a Python package manager. So if you have not installed the UV, go ahead and install it. So the step is very simple, pip install UV. So with UV, it becomes very fast to install the dependencies and manage your virtual environments. So if you see, I'm on version 0.8.22. Now, in order to install the dependencies, first of all, you will have to create the requirements.txt, and under requirements.txt, so if you see, the first dependency that we have added is PyMe PDF for LLM. Now, this PyMe PDF for LLM is going to help us convert all our PDFs into the markdown. So let's install the dependencies first. UV pip install -r requirements.txt. Now we are installing all the dependencies in one go. Okay, you can see it is using Python 3.12. Make sure you are on Python 3.12 so that you will not face any issues. Now currently you will see the dependencies are like this. There is no exact versions added, but while pushing this particular, but at the end I will push the changes where I will add their exact versions that we have used so that you will not face any issues while installing the dependencies. So okay, audited all the packages. All the packages have been installed. I think it was already there. Oh, I made one mistake. Sorry. I did not create the virtual environment. So first of all, we'll have to create it. So the step is very simple. In order to create the virtual environment with UV, you just need to write UV, and when it will create the virtual environment. So if you see, it has created 3.12, used Python 3.12 and created this virtual environment. So if you see, the VNV is added there, and in order to activate it, you need to go to the scripts and you need to run this file activate. So let's go ahead and do that. So they have already given the command. Let's paste this command and hit enter. Okay, so the environment has been activated. Now we can go ahead and run the script to install the dependencies. Let me just clear the screen. Okay, clear the terminal, and again let's hit the command UV pip install -r requirements.txt. Okay, you can see it is installing the dependencies. It will take some time, but yeah, it will be very fast. You can see too many requirements are there, but still it has installed all the requirements within a second. So that's the power of UV. Okay, now this part is done. Now let's move ahead. Go to the PDF to Markdown conversion. Still it is showing the import is not, could not be resolved because we have not selected the right environment, I believe. So okay, it is still showing here, but let's go ahead and select it once again. Interpreter path, find, and this is when you can go to the scripts and you can select Python. Okay, see, now it is referring to the latest environment. So let me do that for this as well. When scripts Python, okay, all set. Now it is, now the error has okay, now the error has gone. So in this code, what we are doing is, first we are converting the PDFs to markdown format, and again we are using PyMe PDF for LLM. So if you see, it is, first of all, we are reading all the files that are available under raw folder. So that is what we are going to pass. So if you see PDF path, we are going to pass, and output directory. Output directory, it will create a output folder in this particular data. Then it is using the encoding UTF-8 in order to convert it. And once the conversion is done, so this is for single file conversion. If you have single file conversion, you can use this. And if you have a directory, you can use this function. As we have a directory, so it will use this. So we just need to pass the input directory and output directory. So the code is pretty simple. So in order to execute that, we use this main function, which helps us execute this particular code or test this particular code. If you're not aware about the meaning of this, then please go ahead and check out that. It is pretty simple actually. Like, this code will be executed, this file or this particular lines after 64 will be executed only if you are running this file with Python PDF to markdown.py, then only it will be executed. If you are importing these modules into another file, let's say app.py, you are importing this PDF to markdown, then it will not execute this code. It will only utilize these particular classes or functions that we have written. So that's the way. That's the benefit of adding this. Now this is quick thing that with which we can test the application. So let's, in order to run this, let's write Python. But yeah, first we'll have to go into the ingestion folder. So let's go into the ingestion and then Python pdf to markdown.py. Now this will create one folder here and it will convert all our PDFs into the markdown format. So let's wait for that. Okay, you can see the markdown folder is now available and it has converted first file. So let's go ahead and review this file. So if you open this file directly, you will not be able to understand pretty much. You will not be able to understand this, but in order to load the file, you can open it in preview mode. So in the preview, if you see, it has maintained the structure, all the details as is. So if you see table, it has maintained the tabular structure, whatever is available. Again, if you see this table of content, everything is maintained properly. And the thing that we saw right below the sales information, total sales. So if you see total net sales and everything. So it has preserved this particular content as is the structure of the PDF. And now it is helpful for us to pass this markdown format to the LLM. Okay, so that was the reason. Now, if you see the code has been executed and it has, basically converted all the files. Okay, now first part is done. So if we go back to our application, logical architecture. So if you see this part is done, converting from PDF to Markdown. This part we are going to build at the end because first we will complete the backend part. This backend part we will complete first. Once the backend is ready, we will connect it to the user interface, right? So once this part is done, now the next part is semantic chunking. So let's work on the semantic chunking. The first thing is we need to deploy these embedding models from the Azure OpenAI. So we need to do that setup. And for semantic chunking, we'll be using an LangChain. There are some classes available in LangChain, which with the help of which it becomes easy to chunk the data, semantically chunk the data. So let's go ahead and do that first. And I'll explain how this chunking is helpful and how exactly what happens behind the scene whenever we are chunking the data. So under this particular, let me close all these things. Now under this particular ingestion, we have this another file semanticchunker.py. And again, if you see, we are importing the document class from LangChain core.documents and we are importing a semantic chunker from LangChain experimental.textsplitter. This helps us chunk the data semantically. And with this, it uses a large language model for doing the semantic chunking. Because it is a semantic chunking, right? Now there are two ways with which you can chunk. You can directly chunk the data or use semantic chunk. Directly means the sense you can decide the fixed length of the text on which you can directly chunk based on your model context window, or you can use a semantic chunker. Just hold on for a bit. I will explain how exactly that happens, or let me explain that for now. So then we can come to the code. So, okay. So in this semantic chunking, we are using embedding model and Azure OpenAI. So why the embedding model is required for chunking? Let's understand that. So let me take you to the, so here I have explained why the semantic chunking and how exactly semantic chunking works. So first, if you see, what we have is this kind of information we have. Like we have paragraph 1, which is related to the Tesla revenue. Paragraph 2 is related to the increase, the sales, increase in the sales. Paragraph 3 talks about operating margin. Then paragraph 4 talks about risk factor. Paragraph 5 talks about the future growth. Likewise, we have multiple paragraphs available in one document. Now, it is impossible to feed all these documents in one go to the large language model because of the context window limitations. That's where we need to do the chunking. Now, in the traditional chunking, if we chunk directly based on the fixed width, what will happen is that if you see, in the chunk one, you will get paragraph 1, paragraph 2. Let's say the paragraph 1 and 2 is equivalent to the length, let's say, uh, equivalent to the length, let's say 1000 character, and your model, for example, supports only 800 character. And your model supports, let's say, 1200 characters. So in that case, what will happen? It will create these two into one chunk because it is still less than the 1200 characters. that is the context window of the model, and based on that it will create create this chunk. Now in this case, what will happen, it will chunk the data based on paragraphs, or it may chunk the data abruptly, like it will take the full paragraph one and half of the second paragraph. In that case, what will happen, your data will not be chunked based on the paragraphs or based on the semantic similarity. It will be abruptly chunked. And the limitation of that, whenever we are feeding this particular data to the model, then you are losing the context, right? Context or meaning of this particular semantic meaning of this particular paragraph. So that's how the traditional chunking works. Now in the semantic chunking, what happens if you use semantic chunking? First, we are using an embedding model. The task of embedding model is to convert our text data into the embedding or semantic vector. So in the semantic chunking, first, let's say the paragraph, it will create embedding vector out of that. For second paragraph, it will create the embedding vector. Similarly, it will create the embedding vector for all the paragraphs that are available. And now the embedding vectors will look like this. Let's say for P1, the embedding vector is this. For P2, it is this. Like this, it will convert those paragraphs, text paragraphs into the embedding vectors. Now, these embedding vectors, we will be utilizing a Azure OpenAI text embedding model. With the help of text embedding model, it will convert these paragraphs into semantic vector. Now, these vectors are semantic. Now, on top of this, we will perform a similarity activity. Similarity activity, how exactly it will be performed? Let's say P1, we will compare it with P2, and then we will identify the score. Let's say P1 and P2, if they are relevant to each other, we will find their cosine similarity. Let's say the score comes as 0.95, meaning 95% these two vectors are similar. So in that case, we will combine these two. We will again move further. We will compare P1 with P3, and if the semantic similarity is 0.88, we will consider P1, P2, P3 together. And if the P4, if we compare P1 with P4, let's say, and if the semantic similarity comes as 0.22, meaning, okay, P1 and P4 are not related because there is a big drop. In that case, you will create a boundary and you will not include P4 into the semantic similarity, first vector of semantic similarity, first chunk of semantic similarity. So that's how the chunking is done. Again, while doing this chunking, again, it takes care of the context window as well, and it makes sure that it is not exceeding the context window. So that's how the semantic chunking is done behind the scene, and that's the reason we need the embedding model. And in the embedding model, again, we are not using this embedding model in order to embed the input query, because there are two algorithms in order to extract the query in the RAG operation. First one is the keyword search, and second one is the semantic or vector base. And there is third approach, which is hybrid, which combines both. In my previous videos on my channel, I have covered the approach with respect to the vector. Also, I have covered the approach with respect to the hybrid. So I thought to cover only the keyword search for now. Again, you can change that approach based on based on your need. But to keep it simple, currently we'll be using a keyword search, and I'll talk about that how exactly it is doing. So once this semantic similarity score is generated, then you can see the final chunking will be like this. Revenue, energy, and operating margin will be grouped together, and risk factor, disruptions, and the regulatory changes will be come under chunk 2. So that's how it will create a semantic chunking, meaning it will do the chunking based on the context available, semantic meaning of those context, and that's how it will chunk the data. So this is what we are coding in this particular part now. So let's go back, and if you see in under semantic chunking, so first thing is it is reading the markdown file that are available from this particular directory, whatever directory that we will pass. Then chunk markdown. So what it will create, it will generate a semantic chunks from the markdown, and for that, if you see, it is using semantic chunker from LangChain. So this is what is the class available in LangChain. What it does, it splits the text based on semantic similarity, and for semantic similarity, it uses a LLM. Not LLM, sorry, it uses the embedding model. And for the semantic identification, it needs an embedding. So if you see, it needs embedding, and these embeddings will be created with the help of our OpenAI embedding model. So once we pass that, so if you see, it expects embedding and the threshold percentile, and then it is going to split it. But to pass this particular embedding, we will have to call the Azure OpenAI model. So if you see, from again LangChain OpenAI, we are importing this class Azure OpenAI embeddings so that we can pass this LLM capability. And these are the parameters that we need to set. These are the environment variables that we need to set into our environment file. So now I'll take you to the environment file.env. Again, there are multiple details available. You can ignore those. Let's focus on embedding. So first of all, we'll have to go ahead and import these details from our cloud resource. So for that, we need to deploy these particular models, embedding models, and from there we will get the OpenAI endpoint as well as the versions. So let's go to the Azure. Now, this is my Azure account. Uh, Now, if you don't have an active subscription, I would highly recommend go ahead and create one. Or if you have a free subscription, please use that. Again, I'm not covering how to create these Azure accounts and all because you will find a lot of videos available on it, and it's pretty simple. So create a subscription or use a free subscription. I'm not sure how free subscription will work because we have a large documents. So maybe you will face some limitations while using the OpenAI models, Azure OpenAI models, because on free subscription there are limitations. Now, first thing that we need to go ahead and do is we need to deploy the Azure Microsoft Foundry. Sorry, earlier it was Azure Foundry. They have renamed it to Microsoft Foundry. So you can search Microsoft Foundry here and click on create resource. Now let's give the names. So we don't have any resource group. So let's create. RG stands for resource group, and I'll give name as investor intelligence. Okay, it's available. And this name of the service, let's give it as investor intelligence. A region is east to west, that's fine. Okay, the domain is not available. So let me give AGF investor intelligence. AGF is Azure Foundry. Okay, which is available. Project is default, that's fine. Next, you can skip these details. Let's click on review and create. It will validate whether the names and everything that we have given is correct or not, or whether it is as per the requirement or not. Okay, so validation is done. Let's click on create. So this will go ahead and deploy the Azure Foundry service for us. So let's wait for this deployment. Okay, so the service has been created. Let's go to the service and let's launch the Foundry portal. So you can click on go to Foundry portal. Okay, now under the Foundry, you can go to the models and endpoints, and here we can deploy the model. So click on model, base model, and here you can search text embedding. There were three models available from the text embedding from OpenAI. Okay, so if you see three models are available, out of which we will go ahead and use the medium one because we have a pretty large PDF. So let's use this. Large is again, it will again incur cost. So let's go ahead and select this suitable one. Click on confirm, and then it will ask us to customize it. So let's click on customize and token limit. Let me make it 150, and let's click on deploy. Okay, so the text embedding model deployment is almost done now. And okay, so we will get this key information. So you can copy this key and you can come to the application in the .env. You can replace this key with that key, whatever we have generated. Now, I know these secrets are exposed over this video now, but I'm going to delete the resources that I'm creating before uploading this video. So you will not be able to use these keys, unfortunately. Make sure you use your own keys. Apart from that, what we will need is this deployment version. So if you see at the end, we have API version 2023-05-15. So 2023-05-15, which I have already added. This is the embedding model version. Endpoint, you can get the endpoint by going to the overview. And here select Azure OpenAI, not Microsoft Foundry, because that's what we are using with the help of LangChain. So let's use this endpoint. Okay, so we have added the endpoint. Let's save it. And then in the semantic chunker now, this is the model name. So you no need to pass the model name. So first of all, what it will do is, as this is for the testing purpose, it will use the file. So let me pass one file, let's say this one. Okay. So from data folder, we will pick this 2024 Apple Markdown file, and for which we will run this chunking. And we'll see how the chunking looks like. So let's go ahead and run this Python semantic semantic chunker.py. Let's see if there are any issues, we'll fix it. Okay, ignore the warnings, that's fine. So this chunking and everything will happen dynamically once user uploads the file. In the backend, it will call these APIs in order to perform the chunking first and upload that data to the vector store. So just for your understanding, I'm showcasing this step by step. In chunking, what actually happens behind the scenes. So we have already understood the logic. We have already understood the phenomena, how the semantic chunking works. Now we will actually see the chunks that are created after this particular processing this particular document. So as the document is pretty long, it may create 20, 50 chunks. So let's see how much it is creating, and definitely it's going to take time. And again, this incurs a lot of cost as well. So at the end, I will talk about how much cost it incur me. But yeah, please, if you are creating a subscription, make sure you are deleting your services once you are done with your usage, and be mindful while calling these services. Don't pass the complete data as is. Like now the files that we have, again, it has close to 100 or 140 pages in the PDF. So it is definitely going to incur a lot of cost. So please be mindful whenever you are working on this. And if you are worried about cost, I would recommend go ahead and slice the data. Out of those PDFs, keep only 5 to 10 pages and then you can try it out. Okay. So if you see the chunks that it has created, so the first chunk is related to the annual report and all that information. The second chunk is, again, it has created. The third chunk, if you see now, the chunks are of dissimilar size, meaning this chunk is this chunk is not too big because it identifies the semantic information. If only this semantic informations are available, then it will only keep it. So if you see, it is related to the indicator, so it is indicating. Then this one is related to, I believe, company's office portfolio, company operates various, the company's cloud, so company information. So that's how it has created the chunks. Now this complete data is created into 23 chunks, as I mentioned earlier, right? Because the document is pretty big and we are only printing top 3 chunks. Now these chunks are the semantic chunker. So based on the semantic chunking method that we saw, it is doing this chunking. Now this part is done. Now the next part is we need to ingest this semantic chunks into the vector store, and for that we need to create the vector store. So if we go back to the diagram again, so this semantic chunking is done. Now the next part is creating the vector store, which is our Azure AI search, the cloud service from the Azure to keep your embeddings. And we will use this vector store in order to serve the user interface later on. So one thing I missed to cover is how this, yeah. And once this vector store is done, then we will see how the extraction will happen, how we are going to extract these KPI information. So first of all, let's go ahead and create this service. So again, I'm going back to my service, and now we have created the resource group as well. So let's click on Azure AI search and let's click on create. Here we will select the existing resource group RG inventory intelligence, and here we will give name as, let's say, AIS intelligence. Let's see if it is available. It's available, and you can go to the pricing and change the pricing if required. Now the free service is also available. You can utilize that. I'm going ahead with the basics one because again I'm having a big data. If you are chunking the data, select the free one. So I'm selecting it, review and create, it will create it. Now with this, I'm getting 15 GB partition memory, max 3 replicas, meaning the complete data will be partitioned first and it will be maintained into 3 different replicas, meaning there will be 3 instances created for each of the data. So this is required in order to speed up your serving activity. Meaning, let's say if 100 users are coming and retrieving the data. So in that case, let's say one replica may be sufficient. You can serve that. But what if 200 users are coming and you are facing load on your application? So in that case, load on your service. So in that case, it will retrieve the information from the surrounding replica, from the another replica that it has created, so that it manages the flow. Okay, let's go ahead and create it. Manages the flow in the sense it helps us better serve the application. So that's the reason it creates the replicas. And again, these replicas and everything is very important once you build the high scaled applications. Once your user persona, once your user repository is pretty big, you have thousands of users accessing the application, then in those cases it is helpful. Okay, the service is created. Let's go to that service. And in the indexes, currently we don't have an index. So if you see, the index is empty, and we can get the information from the security and networking, click on the keys. First of all, let's copy this key because that's what we need to pass it. So if you go to the ingestion documents and if you scroll down, you will see what we need is Azure OpenAI model that is required in order to perform this embedding. Then you need search endpoints. So again, go back to your environment and we need to pass these details. So search API key, let's replace this key with the one that we created. Next, go to overview and you can copy this. I think it's going to remain same because I created with same name. Okay. And the Azure index name, you can give it as financial document. You can keep it as is. And already we have given the embedding model name and embedding endpoints and everything. So we don't need to pass anything related to that. Now, once we execute this particular code, ingestion code, what will happen? First, it will create the embeddings. It will create a vector, the index, and into that index, it will ingest this particular data. And in which format it will ingest, let me show you that. So first is parse a company year. So first of all, it is extracting the company name and year from the file. So make sure you use this file name like 2024 and Apple. So 2024 is going to be year and Apple is going to be company name. Again, you can change this method. You can use another method to identify that because these two are the key parameters again because we do some partitions on the UI. So it's for, we apply some filters on the UI. So it's for that purpose. Now, once we extract that details, then ingest document. So we need to pass the PDF path, embeddings, and vector store. Now in this, if you see, first we are reading the markdown file. We are performing the chunks out of it in the same way we saw in the semantic chunker. And then we are creating the vector store.upload. So with vector stores.upload, we are uploading this metadata. So let's go ahead and run this file and then I'll show you what are things that it has uploaded. So let's save it and let's run this file again, Python ingest documents.py. Let's go ahead and execute this. No module name ingestion. Okay. Let me check. Okay. It is saying no model name ingestion because we have not created a constructor here. So let's go ahead and create a new file and give the name as underscore underscore init underscore underscore dot py. This will make sure to mark this project, mark this particular folder as a module, and from here it will be able to load these particular modules like semantic chunkers and everything. It will be able to load. Okay, as we have created the constructor, so let's go ahead and run this. So in order to run this, we need to run it as a module. So first we need to go back to our main folder. So we are currently at this folder, AI powered investor intelligence, and here we need to run this as a module. So in order to run this as a module, we need to select -m, which stands for module, then ingestion, and then we, instead of forward slash, we need to use dot, and then after the dot we need to pass the file name, that is ingest documents, and we no need to give the extension .py. Just go ahead and execute this. Okay, so once we execute this, it will go ahead and run this particular file as a module. So it will be able to load all these data. So if you see, it is loading the Apple file. It has found 3 files and loading the Apple file. So I think we have only selected Apple file out of all the files that are available. Okay, it is ingesting everything from this particular raw. So what I will do, I will interrupt this once this particular ingestion is done for the first file, just in order to save the cost. Okay, generated 23 chunks for the Apple file. Again, it has generated the chunk because now we are calling the semantic chunk module here itself. There is one issue that we received. Financial documents for services was not found. Okay, let's see what's the issue. Let's go to the environment file. Endpoint we have changed. Key we have changed. Financial documents we have changed. Okay, one issue that we are getting is this particular index is not found. So what we need to do is we need to go ahead and create the index. So to create the index, I have written the code into the vector store. So if you see, if you expand the vector store, you will see Azure AI search.py and create index.py. So create index.py, what this file will do, this file will go ahead and create this particular fields, and it will create the searchable fields that are required while creating the index. So here we have defined the indexing format, and let's go ahead and execute this, and then I'll talk about this file. So let's go to vector store, and here run python create index.py. This will create the index, and I'll show you once the index is created. If you see the financial index document index is created, so let's go ahead, go to the index, and let's refresh it. It should show the financial document. So if you see, it has created. Now under the fields, if you see, these are the fields it will be utilizing. First, it will utilize company, year, source file, content, and content vector. So if you see, these files are retrievable, filterable, and they are searchable as well. So content is searchable, if you see. So whenever we will hit any query, it will search that into the content, right? Now let's go ahead and check that, the code. So in this code, if you see, we have already given these details. Simple field ID, and it is a key. Then if you see, on the content, searchable equals to true, and on others, filterable equals to true. Meaning what we are doing is we are searching the content, whatever query that user will search. Let's say if user is searching for give me the total revenue for Apple, so it will search revenue for Apple into this content. It will retrieve that, and then these filterable fields are there. You can filter it based on apply filter based on company, that okay, user wants the detail only for Apple, so it will filter the details and it will only retrieve the queries that are related to the Apple. This is in order to improve the accuracy. So that's how it will go ahead and create the index. Now, in order to retrieve the data, we are using keyword search. How the keyword search works, let me explain that quickly. Okay. So we are using this particular algorithm BM25. What exactly is BM25? BM25 is best match 25. Now 25 is just the experimental number. After this trying this particular best match algorithm for 25 times, they obtain a good results on this particular experiment. That's where the name given BM25, which is best match 25. If you are interested, go ahead and check out the paper. I'll try to drop that link in the comment sections. In the description, you will go ahead and read about that. Now, for example, how it works is, if we ask the question, what is total revenue, let's say. So in this case, what happens? First, it will retrieve the document, let's say document A, total revenue increased to 100 billion, and it has extracted the document, risk factors include inflation. User is asking this question, it has retrieved these two documents. Now document A is relevant, document B is not relevant. So then it will identify the score. Let's say for document 1, the score is 0.98, and for document B, the score is 0.1. So it will say that, okay, document A wins, meaning for this particular query, the right document to extract is document A. But how this BM25 works, it works on the principle of the count of words that are available. If you are aware about the TF-IDF process, term frequency and inverse document frequency, so it works on the principle of TF-IDF. Let's say it will first check how many times this total revenue is available. So what it will check first, it will take the word total revenue. It will check the total revenue is available in this particular document. It's not available in this document. So the count of total revenue occurrence in this document is higher than this document. So based on that, it will calculate the score, and that's how the document will be selected. No semantic similarity while doing the keyword search. It is doing a keyword based search. It will directly search the keywords. We use semantic search where we convert this particular vector into embedding. That vector then we pass, that vector then we compare it with the vectors available into our vector store, and then we calculate the semantic similarity. That step we are not doing. We are directly using a keyword search, that is BM25 algorithm, again, which is very popular algorithm nowadays, and most of the organizations are using it over embedding because it saves your cost as well. You don't need to spend a token in embedding this query and embedding the existing chunks as well. So that's the reason the organizations are using this BM25. Now let's go back to our code. Now the index creation is done. Now we can go ahead and upload the chunk. So for uploading the chunk, the code is written in this file. So if you see, the documents that we are uploading after from the chunks is this. First, the ID, the company, year, source file, content, content vector. These are the details it will be dumping into the vector store. And for the retrieval, this is the code which we will talk about. So as I mentioned, we are using a keyword based search. So if you see the filter expressions, once the document is extracted, it will filter that document with the help of company and year, so that it will make sure only the relevant entries are extracted. So here we are using top K as 20. It will extract 20 documents, out of which, let's say if you are retrieving the document or content only for Apple, it will filter out that for the Apple. So that's how the extraction will work. Now let's go to the ingestion and let's run this particular file. So again, come back one step, come to the base folder and run this file, python-m ingest documents. So this will now check for that ingestion, and if you see, it has started the ingestion of this particular file. So first it will do the semantic chunking, then it will that semantic chunking, it will upload it into the vector store. So let's wait for that. Okay, you can see it has generated 23 chunks. Now it will load those chunks onto the vector store, and then it will pick up the second file. Okay, uploaded 23 out of 23 chunks. Okay, now I'm getting this error because uh, the model that I'm using, right, it has hit the limit. It was able to uh, embed all the chunks first, but now for the second semantic chunking, the model is failing. So I'll have to increase the rate. So the rate that we set right here, again, if you go back to the Foundry and if you go to the models and endpoints, if you click on edit, you can increase the rate here, but if you increase the rate, it will incur cost as well. So this rate, currently we have set it to 150 because we have large files. That's where it is a challenge, and that these are the real challenges that we face in the industry. Because what happens when you do a toy project, right, or a POC, you pick very sample data set, very small data set, and the application works smooth on that particular documents. But when it comes to the actual documents, these are the challenges that you face, and then in those cases you will have to improve this, or you will have to add a wait timer so that it will wait for a minute once this particular error has obtained in order to avoid the interruptions. So that's how we handle it. For now, let's ignore it. One file is uploaded successfully, so let's go ahead and check that. So now I'm going into the documents. It will take some time to reflect those documents, so let's go ahead and refresh it. So it will definitely take some time, but yeah, I'll show you it. If you start searching here, let's say Apple, it was related to the Apple, so it will extract the details. So if you see, it is retrieving the detail. This is the ID, company is Apple, year is 2025, source file is this, and content is this. So yeah, that's how it has created a dynamic ID, and that's how it has stored the data. Now, whenever user is searching any question, it will be matched with this particular content. It will retrieve the content and then it will filter it for company Apple and 2024 year. So that's how the filterable and searchable components will work. The one that we discussed here, right? The company and years are filterable, whereas the content and string, that is searchable. So that's how it's going to happen. Now, this part is done. We have done the ingestion. Let me show you if the documents are available now. Okay, so if you see 23 documents, 23 chunks that we saw here. So if you see 23 chunks it has created, it has uploaded all the 23 chunks. It took this much memory. Max storage we have 15 GB. So if you are using one file, then you can go ahead with the free service as well. Okay, this part is done. Now our vector store ingestion is done. So if you go back to the whiteboard, now here this part is also done, vector store. Now we need to build the logic to retrieve the content out of this. So now we will actually hit to the vector store and retrieve the content related to the revenue, the total sales, assets and everything, risk and growth. All those KPIs we will retrieve it from the vector store. Then we will pass it to the GPT-5 model. So let's go ahead and dissect that particular part as well. Okay, so as the vector store ingestion is done, now we can work on retrieving the content. So let's go back and see our workflow. So this particular part is done, vector store ingestion. Now let's work on this KPI extraction. So we need to extract these KPIs. So let's start working on it. So for that, again, based on the modular code that we have written, you can go to this particular rag operation, because now it's the retrieval, then we will augment it and we'll generate the output. So it's the rag operation that actually will happen here. So I have created a constructor in order to mark this particular folder as a module. Let's work on this KPI extractor.rag. Sorry, KPI extractor rag.py. So In this code, so first of all, we are importing the LLM because now it's a RAG operation. First, we will retrieve the content, feed it to the LLM, right? So this part we are seeing now. First, we will retrieve the content and then we will pass it to the GPT-5 to generate the structure output. So this part, now we are going to see it together. So let's work on it. So first of all, we will need a LLM. So let's go to this particular code. So which is written under LLM. So if you go to this LLM and if you expand it, you can see Azure OpenAI.py. Now here we need these three details, the Azure OpenAPI key, which we already have it, then Azure OpenAI API version and the OpenAPI endpoint. So again, let's open our .env and we need to grab these details. So we need these details now. Key we already have, we need OpenAPI endpoint. Then this one for chat model, we have already created it for the endpoint. Now we need it for the chat model and the OpenAPI version for the chat model. So let's go to the Foundry and we will create these services first. Okay, so let's come here again, go to the models and endpoint sections, click on deploy model, deploy base model, and here let's select GPT-5. We'll be using a GPT-5 chat interface model. So let's select that. If you scroll down GPT-5 chat completions, if you see this is the model that we'll be using, let's click on confirm. You can use either GPT-5, you can go ahead with GPT-4 as well, 4o as well. So let's click on customize and it is selected 150k token. I think this is more than enough. So let's go ahead and deploy it. So it's creating the deployment, should not take much time. Okay, the deployment is done. We got the endpoint. So let's copy this endpoint and we will pass this endpoint here, chat endpoint. So let's replace this with the endpoint. Okay, the endpoint we have replaced it. Key is already same. So if you see, it starts with 7f and ends with fd. I think it's the same key. Start with 7f, ends with fd. So okay, key is same. Version. So you can get the version from here. So this is the version 2024 1201 preview. Okay, the same version is added. So that should work now. Okay, so this part is also done. Now come to the this one, and again it is importing the Azure AI search vector store from vector store.azure AI. So if you go to this, so if you see this is a file under vector store where we have written the code for retrieval. So if you see we have a retrieval class which is retrieving the top 20 records from the vector store, and it has a code to connect to the client as well. So client in this is it connects to the Azure AI search as well, right? So if you see here it is connecting, creating the client. So let's go and let's deep dive into this code, KPI extractor. So if you see this is the retriever, we are retrieving it. Then this is the content that we are retrieving. We are passing this particular query while retrieving the content. Now we need details related to the annual financial statement, income statement, balance sheet, cash flow statement, risk, growth drivers, financial performance for the company that we will pass and for the year. So this query will be hit to the vector store and out of this it will retrieve the document. First of all, let's hit this query on the Azure vector store. So let's go to the AI search and here we'll try to hit this query and we'll see what information that we are getting. So instead of here, let me pass year 2024 and for company, let's pass it as Apple and let's search it. Okay, so if you see it is retrieving the content related to the financial statements and other information related to the sales and everything, right? So this is what it will return the top 20 results, and these results then we will feed it to the LLM. So if you see in the documents, we will get those documents and then we will pass the document into the build extraction prompt. Here we are building the prompt. This prompt we will be passing it to the LLM GPT-5 model. So if you see you are an expert financial analyst for this particular company, this is the context that we have retrieved. Extract the following information out of that revenue and these top 8 KPIs. So we are retrieving that top 8 KPIs out of which, and this is the instructions that we have given. Return only a valid JSON object. And then we have added extract financial matrices, the final code where it is coming, accumulating all the details. Like first it is retrieving the content, then building the prompt, and then the extracting the matrices. And in the main function, if you see, first the retrieval will retrieve it, then it will pass that retrieval to these particular results and it will generate the final result. So first of all, let's see if we can print the context that is retrieved. So let's go ahead and click on print here. We are printing the context, and let's for now we can comment this step, passing it to the result. And let's comment this one as well. Okay, we'll have to comment everything, and let's run this particular file. So it should go ahead and retrieve the content. So to run this file again, we are at base folder, so we'll be using an Python module. So Python -m, and it's under rag dot KPI extractor. Let's go ahead and execute. Uh, no module name rag KPI extractor. Let's see. Okay, KPI extractor rag underscore rag. Okay, so it should go and retrieve it. Okay, it is not printing it. Ideally, we should print not context. We should print the retrieval. So if you go to the retrieval documents, you can print these documents here. And now let's hit the query. Oh, sorry, we'll have to enable this part. Now let's see. Now it should go to the vector store and retrieve. So if you see, this is the document that it is retrieving, the exact document. So if you see top 20 results, these are the top 20 results available in the document. We are passing this information to our large language model. So if you see, it starts with 2024 form 10K20. That is what exactly is retrieved here. So if you see form 24 10K20. So it is doing the retrieval task. Now this retrieval, what we have done is, as part of this, we have retrieved the information. We are passing this to the LLM to extract only this part in the JSON structured output format. So now let's come back. Let me comment out that cell that we added, the print statement. And now let's enable this, and we will print the extracted results as well. Okay. Now let's go ahead and execute this. Clear it, and again let's execute Python -m rag kpi extractor dot kpi extractor -rag. Now it will extract the actual documents out of it. Okay, let's see what's the problem. OpenAI does not exist if it is created within last okay resource. Okay, might be something is wrong in the environment. Let's go ahead and check it. OpenAI version is correct. Chat OpenAI endpoint is correct. Model name, I think model name is misleading. Let's check the model name in the deployed one. Okay, so the model name is GPT-5. So we'll have to replace this with GPT-5. That was the issue. Okay, quick fix. Let's go ahead and execute this again. It should work now. Now it is hitting the request to the vector store, retrieving the content. Retrieval content it is passing to the LLM, GPT-5, and LLM is getting the structured output out of that. All the 8 KPIs that are required to showcase on the user interface, it is retrieving that content. So it will take some time. So let's wait for that. Okay, you can see it has retrieved the content. So if you see, this is what it is retrieving. This is the revenue and all this, and these are the top risk factors and top growth drivers. So this information is retrieved by the GPT-5 model out of that document that we passed. So isn't it interesting? So it's working. And if you see expected KPIs, these are the KPIs we have printed. So it's just printing it again. Meaning this retrieval part is working, and this is what we wanted to showcase on the UI. Now, why structured output? Because this JSON object, we will pass it to the user interface. This backend API, right, it will return this JSON object, and the UI will consume this backend API response. So that response should be in the structured format. Then only the UI will work. So that's the reason we are generating it in the structured format. Okay, so this is cool. It is generating this data. Now, the next step is we need to ingest these matrices into the SQL database, because if you remember, we discussed in the diagram here that once the AI search retrieves the information, it is a one-time extraction which will be ingested into the SQL database. So this part is now going to happen, retrieval ingestion. So let's work on this. So for that, we need to create this Azure database for PostgreSQL flexible server. So again, let's go to this Azure portal and let's search for Azure Postgre. Okay, once you search, you will see this Azure database for PostgreSQL flexible server. So let's click on it. Let's click on create. Again, this is again a costly service, so please be mindful while using this service. So I'm selecting the existing resource group. Then dev production, we can select dev because that way will incur a less cost. It will incur a less cost, and this is the machine that it will give us: 2-core CPU, 4 GB RAM, 32 GB storage, which is more than enough for us. Again, it is overkill for us, but that's the minimum available. Availability, no preferences, and here you can select the PostgreSQL authentication only. And for this, you can add a login. So you can use your login. Let me use my login so that I no need to change this particular env file. So administration login, let's use itech. Password, I'm using this password, rag @12345. So let's use that rag password. And let's add the confirm password. So this is done. Let's click on next and review and networking. So if you see the estimated total cost, it's close to $58 a month, which is pretty big number, right? And that's where once you are done with utilizing the service, please go ahead and delete the service. So let's click on next. Public access is enable. Next, review and create, and click on create. Okay, something is failing. Okay, server name should not be empty. Okay, let's pass the server name as investor intelligence. Okay, let's review and create. This you can skip it. Create server without firewall rules. Again, firewall and all, right, it is required once you actually work on the industry. You need to take care of the security perspective as well. So you need to add the IP address. For those IP addresses, only this particular service will be utilized. So basically, you'll be doing the IP address whitelisting and all that stuff. But yeah, for us, let's ignore that part because we're not going into the security details. But yeah, if you guys are interested and if you guys want me to cover that as well, maybe you can drop that in the comment sections. And in this series itself, at the last, I will cover those details as well. So I'm going to extend this series. Basically, we are going to cover the CI/CD and everything, right? The deployment as well. So this is going to be the pretty interesting one. So this will take some time to basically deploy this service. Once this service is available, we just need to grab several details and we need to drop those details into the env file, and then we'll be able to connect to this particular server. Meanwhile, we can go ahead and install the pgadmin. Pgadmin is a tool which is helpful in order to connect to this particular server. So it's an application just like our MySQL. For connecting to the Postgres server, we have a pgadmin as a tool. So you can go to the pgadmin and just install the pgadmin. So you can go to the download sections, and based on your application, based on your system, you can go ahead and download. So for Windows, I have a Windows, so I have downloaded this latest released on the May 11th. You can download it, install it. Once you install it, it will look something like this. Or let me close all that stuff. Yeah, so once you install, it will look something like this. And here you can connect to the Azure SQL that you are creating, the PostgreSQL. So let's wait for that creation. Let's refresh. Yeah, it will take some time because it's a database creation. Okay, so if you see the deployment is succeed, so let's go to the service. So this is our Azure database for PostgreSQL flexible server. So first of all, we need a endpoint detail. So you can see this endpoint, you can copy this endpoint, and we need to pass this endpoint into our code. So if you see this Postgre host, let's replace this host with the one that we created. Okay. Now this part is done. Port is same 5432. Database name is this one only, financial intelligence. Postgre user is itech, that's what we have given, and password we have given rag @12345. So we are good. Now we can go, and if you see under the connects, you will find the details with which you can connect to this particular server. So if you click on this pgadmin, right, the one that we have installed, you will get the details and all things that is required in order to connect to that. Plus, if you select VS Code, you can directly connect to this particular service through VS Code extension as well. So there are a couple of ways available with which you can connect. Now what we are going to do under the database sections currently, if you see, these are the default database that it has created, but we are going to create our own database. That is financial document. So that's what we have defined here. If you see financial intelligence, sorry. So what we can do, we can now connect this to our PG admin. So you can come to the PG admin and you can click on create server group, and let me give name it as intelligence is the group. Let's save it, and under this group now we can go ahead and register a server. So here we just need to give the name is our investor intel, that's the name. And under which, if you go to the connections, we need to pass the host name or address, so those we can again copy from here. The same thing, first we need to pass the host name. Port is similar, 5432. Postgres maintenance database name we need to change it to the financial intelligence. We'll be creating it. Then username is itech. Itech is our YouTube channel, so if you have not subscribed to the channel, please go ahead and do that. That's what we have mentioned. And the password, so let's grab the password as well and we will add the password. So this is the password, and done. Save it. Now financial intelligence is not available, so let's see if it is throwing any error. If it throws the error, first of all we'll have to go ahead and create this. Okay, so unable to connect, so that's fine. First come to the code and you will find the folder called database. So let me hide all the rest of the details. Under database, if you see, we have create table .py. So you can go to this. First of all, we will have to create the table. So first it will create the database and then it will create the tables underneath. So first of all, let me hide this and we will create the database. First, it will check whether the database is available or not. Where we have defined that, so if you see, we are importing this particular create database and get engine from the PostgreSQL, so from this file. So if you go to the PostgreSQL, here we have defined these details: host, port, user, password, and database name, right? Postgre database. So this is our engine which helps our code in order to connect to the PostgreSQL with the help of these connection details. So it is here we are building the connection and it is connecting it, and then this is the code written in order to create the database first, right? So if the database is not available, then it will create. So these queries, it is just checking whether the databases exist or not. So again, if you go to the create table.py, here we are only running this particular first file. So again, in order to run that, we'll be using modular approach. So python -yum, and it's available under database dot create table, and let's execute. Could not translate host name. Okay, why it is picking DB? I think there's some issue. That should not happen. Let's go to the PostgreSQL. We may have hard coded something. Let's check that. Oh, I think this file is not saved. Yeah, now it should work. Let's execute this. Now it should work. Sorry, the .env was not saved. Now it will pick up the latest name and it will basically connect and create the database. Once the database is created, I'll show you that on the PG admin. Now with the help of engine, it is connecting to the PostgreSQL, the flexible SQL server that we have created. And once the database is created, we will go ahead and create the table as well. Okay, we faced one issue. Connection timed out. Failed to connect. Is the server still running? Okay, let's check. Looks like there is some issue. We can come to the overview. Let's enable. The firewall was blocking this, so we will have to update the connection security settings. So let's update it. And let me see if there is anything that I have missed. Okay, now the service is available. Earlier this was blocked, so we have now enabled it. So let's go ahead and run this file again. Now it should work. Okay, so if you see, database does not exist. Creating database financial intelligence created successfully. Okay, so you can go to this portal and you can check here under databases section. You should see the financial intelligence. If you see, this is the database that is created. Now, how to view this? Again, you can go to PG admin, and now whatever details that we have mentioned here, financial intelligence and all, let's give it a try again. So let's click on save. Now this should be connecting to this server that we have created. Okay, you can see the server connection is successful. And if you expand this inventory intel under databases, you will find the database that we have created. If you see, financial intelligence is the database that is created. If you expand this, and there is this schemas, under schemas you will find the table information that is available. So currently there is no table that we have created. So let's go ahead and create the table first. So again, come to the code, and this is the table that we'll be creating: ID, company, year, revenue, all the 8 matrices along with the ID. And one more column is there, created at. So 10 columns we are creating. So let me enable this now, and let's run this file again. So this should go ahead and create the table. Okay, database already exists, so it is skipping that. So it should go ahead and create the table now. Okay, financial metrics table created. So as per this query, it has created the table financial metrics. Now let's go ahead and check that. Here again, let me just refresh it. Okay, so under this particular public, if you expand the table section now, you should see the table. Okay, you can see financial table, sorry, financial metrics available. Now let's query this particular part. Let's open the query tool. This will take us to the query tool, and here you can run the command select star from financial metrics. And let's run this. Okay, so if you see, this is the table that it has created with all these 10 columns, and currently there is no information available. Now, as part of our this activity, we have created this PostgreSQL server as well. Now we have this structured output that is obtained after the GPT-5. We just need to pass that output to this particular code so that we can ingest to this part, so that we can ingest it into the PostgreSQL. And once that ingestion is done, then only the leftover part is creating this user interface that we will talk about. So again, come to the code, and then you will find this particular part, metrics.py. It is this file is the serving file. I'll come to this file later on. First is the save matrices. So with this, we are saving these matrices to the database. So in the ingestion file, we have restricted some of the details. So to test this particular save matrices, what I have done is, so if you see, we are importing the PostgreSQL get engine, the engine that we discussed to connect to the PostgreSQL. Then insert into financial metrics. This is the query that we are using to ingest. Now again, we have hard coded the table names and all those details. You can keep it dynamic. So when you work on the actual industry projects, you parameterize all these values into the environment file, and accordingly you call these values, so that if you want to change the tables and all those details, you can do that later on. Now, this is what the parameters that we are passing, and we'll be ingesting these parameters. These parameters we are getting it from the Azure OpenAI. But for now, I have created a sample matrix that we can go ahead and test the ingestion. So company is Apple 2024, and this is the matrix. So let's go ahead and test it. Again, to run this, we can use, okay, it is getting, my face is hiding this particular, so sorry for that. Python -m, and then again it's under database dot save metrics. Let's hit enter. Oh, no module name save metrics. What's the problem? Oh, spelling mistake, sorry. Now this should go ahead and ingest the data into the vector store, into the SQL server. Okay, successfully saved the matrix. So let's go ahead and double check. So again, now I am executing this code. It should see one row. Okay, you can see first row, Apple 2024. This is my revenue, net income, operating income, cash flow, and all this information, risk factor. Then we have the growth drivers, and at the end, the timestamp when it was created. So this is the today's timestamp. So okay, it's working cool. Now this information will be served to the user interface as we discussed here. Now this part is also done. It will be served to the user interface, but currently we have passed a fixed format here, a custom data set, but now we just need to connect this part to this one, so that whenever the KPIs are extracted, it will be directly ingested into the PostgreSQL as a one-time activity, as we discussed here. it will be ingested into the PostgreSQL. So that part now we need to work on, and also we need to work on configuring these particular complete RAG. Once the user ingests the report, it should go ahead and do this activity simultaneously and ingest everything together. So we need to map all these. So what we will be doing is we will be creating a backend APIs where we are going to wrap all these functions together. We are going to call it and we are going to build these routes, and those routes we will call it into the app.py file to execute it. So now the important part of the code is connecting it. So in order to connect this, so if you go to the RAG folder and under KPI extractor.py, at the bottom we have this particular code which does that activity. So in this code, we were getting the KPI matrices. Now, if you enable this, it will go ahead and dump this data into our vector store. So if you see save matrices, we are calling it from the database. So the same file we are calling, same module, the save ingestion, save matrix, sorry, this one. Now, and as I mentioned, as we ran this particular file, that's where this underscore underscore main function worked. But when we are calling this into the KPI extractor.rag, it will skip that part because now we are not running this file as a main. It is imported as a module. So it will execute whatever information that we will pass from this particular Python file. That was the reason. So let's go ahead and now execute this file again. So Python, it's under, sorry, Python -em, it's under rag.kpi extractor underscore rag. Now this should again retrieve the content. Again, it's a one-time activity as I mentioned. So in the UI, we are going to configure it in the same phase. Whenever user uploads the file, it will call this particular function one time and it will save those KPIs. So now it is again hitting to the vector store. From vector store, it will retrieve the content, pass it to the GPT-5 model, and from the GPT-5 model, it will, so from the GPT-5 model, it will generate the structure output and ingest that into the PostgreSQL now. So let's wait for this. Again, it will take some time. So okay, so if you see, it has extracted the matrices. These are the matrices. Now these matrices, it will pass it to the PostgreSQL. So if you see, successfully saved the matrix for Apple 2024. Let's see whether the new entry has been made or not. So let's go ahead and again execute this. You should see the two records. Okay, you can see second, same information it has extracted because eventually we have retrieved the same content. But if you see the timestamp, there is a difference in the timestamp. It was around 54th minute. This is around 57th minute. So that's how it is doing the whole operation. And the metrics.py file that I mentioned here, right? Again, we'll come to that file, metrics.py. This is basically pulling the latest. So if you see this particular uh, query that we have written, it is checking if there are more than one commonalities across the company. So if there are two times the companies occurring for the same year, then it is pulling the latest one that is available. So on the UI, you will see only the latest record. So that's how we have enabled it. Okay, so we have built 90% of our application. From this point till this point, everything is set up now. Now the next thing is we need to accumulate these into a routes and we need to build an user interface. Now, for the user interface, again, as we have used HTML and CSS, so you will find two folders created under this. One is static, where we have the styling information added for the user interface. And then we have templates where we have defined the template, right? Where should these particular components should be there on sidebar, there should be chatbot and all that stuff. So that is mentioned here. But the one thing that we need to try it out is first the routes. So if you go to the routes folder, you will find all the routes that we have created. Now the first route is for ingestion.py. So if you see /upload is the route. Whenever we are calling this route, again, we have imported all the functionalities here. So if you see from the vector store.azure, we are importing this. From LangChain OpenAI, from ingestion, we are importing ingest document. And that we are calling it in this route in order to perform that activity. So that's how we have created the route for checking the health. We have created the route for dashboard, showing the dashboard matrices. So if you see get engine matrices, the same query that we have written. Chatbot.py, this I missed to cover. So this part of the application, this chat interface. So whenever user asks any follow-up questions or any query, those queries will be hit to the vector store and vector store will generate the GPT-5 output. It will be responded back. So that part is again covered. So let me go over that as well. Under routes, you will find this chat.py file. So if you see in this chat route, this is the prompt. It is hitting to the vector store, getting the response, and that response then it is sending back to the user. So if you see first here, it is retrieving the content. That retrieved content, it is generating the final response by passing it to the LLM and generating the final result answer. So that's the thing. Now this part is also done. So what I have done is I have created one main.py where I have accumulated these backend APIs, at least few backend APIs. So let's go ahead and check this. Again, main.py, we are using fast API in order to build this framework. Fast API is a Python framework to build the backend applications. So if you see first, we are giving the title. This is the initial title that I gave. Let me change it to investor intelligence. This is just for the testing purpose. First, we are checking health of the application, then ingestion and the dashboard. Those two things. Chatbot is missing here, but yeah, you can go ahead and add that. So to run this, you can again use Python main.py, simple thing. This should spun up the user interface for us. Okay, you can see. Let's go to this. Oh, sorry, it is opening in here. Let me go to the, and here you can go to localhost 8000 port. Let's see, it should open the 8000 port. Okay, there is some issue. Let's check whether it is taking us to the docs page. Okay, let me see what's the issue. Okay, so there was a small mistake. So actually it is running on port 8080, not on 8000. For app.py, I have kept the port 8000. So that was my mistake. So let's go ahead and run the application again. Okay, so you can see it has loaded this particular application. So let's go to the localhost and test it. So localhost, and we'll have to go to the port 8080. And if you go to the docs, so if you go to the base, you will see details not found because we need an Swagger page in order to test this. So the Swagger page of FastAPI is available at docs. So /docs you do, and you will find these APIs. So currently I've just added one API. So if you tried it out and execute this, you can see it is healthy. And second route that we have added is the API matrices. So if you try it out and execute it, it will retrieve the information related to the Apple. So few things I have just for the testing purpose, I have hard coded this Apple and all those details, but it is retrieving these content from the vector store, from the data that is we have ingested into the PostgreSQL. So if you see ID2 and then Apple and company, so that exact data is available under this PG admin. So ID2 and this Apple and all that information. So it is extracting that. And the same query it is using in order to avoid the duplicates and all. So that's how we have written other backend functionalities, and those now is getting utilized into the user interface. Now in this project, we don't have separate microservice for backend and user interface. That's where all the APIs are not available on this page, but I've integrated those directly into the user interface in the app.py, and I'll show you that. But when you work for the industry, you ideally create separate microservice. So in this page, you will be able to see all the APIs that you have written. Plus, you should see the authentication as well. So currently, the authentication is missing here. We don't see any authentication available. So, or else you will see the authentication part. First, you will have to authenticate the application. Then only you can access these APIs. So that's how the secure mechanism is built in order to access the APIs as well. So this is for the backend API with the help of fast API that we have built. Now let's go ahead and see the user interface code. Now let's terminate this, and that code starts from the app.py. So this is our final file where all the integration code is written. So if you see first, we have the APIs in order to ingest, then we have API in order to chat, then we have the templates and static folder that we have written, and this is the complete code that we have written and which runs on 8000 port. So first of all, let's go ahead and execute this. But as I mentioned, right, this user interface related code is available on these two files. And again, I'm not going ahead with these files because again, it's not that important because you can build this particular user interface, and ideally we are not responsible to build the user interface as a data scientist. So that's where you can skip it. And now let me go ahead and run the file python app.py, which should load our actual application. Okay, it is running on port 8000. So let's go to the user interface and let's go to the localhost 8000. So you should see the user interface now. If there are any issues, we'll fix it, but let's wait. Okay, cool. This is the final application now that we have built, which is where if you see, we can see the data for Apple now. We don't have the information related to the other two that we have ingested because that information is not there in the the Microsoft and Tesla information is not ingested yet into the vectors into the vector store as well as into the PostgreSQL. So again, I think you might, so, and on the right side, this is our, what we can say, this is our chatbot that we have built. So here you can ask the questions, you can select the companies and ask the questions. And below, if you see, we have these matrices, the growth matrix and the top risk. Again, you can select the, from this filter, you can select the company as well. So currently only one company is there and only one company is ingested. So that's the reason. So, and here you can see iTech. So if you like this particular series till this point, please go ahead and give it a like and subscribe to the YouTube channel as well. Because I'm putting a lot of efforts in coming up with these good projects, a real-time industry projects in front of you, and that too on YouTube. I'm sharing all the details, all the resources, code, everything I'm sharing. So it's totally free, accessible to everyone. So at least I'm expecting this like and subscribe and comment from your side. Okay, the next part is now let's test it whether the application is working. So let's click on ingestion and let me go to the folder and we'll ingest the data. So under data we have raw PDFs. So let's ingest the Tesla PDF now. So if you see now the uploading is going on and let me show you the code meanwhile. So it will print. So if you see ingesting Tesla 2024, company Tesla year 2024. So this particular ingestion has started and you can see on the UI it is uploading the data. So it will take some time now. Let's wait. So here you will see all the processes that are happening. And once this particular data is ingested, then I'll show you how it is ingested into the PostgreSQL as well. So everything is happening automatically now. I'm just hoping it should not throw the error because of the large language model that we have used for embedding, or else we'll have to increase the limit of that model. So let's see if it fails, well and good, we will fix it. That's fine. Failures are always good because that way we get to learn new things. So let's wait for it. So if it fails, we'll go ahead and increase the limit. Okay, you can see generated 21 chunks for the Tesla file. So for the Apple file, we created 23 chunks. Now it has created 21 chunks for this. Now it will load this data to the vector store first. Then it will retrieve the content out of that, the KPIs required for the user interface. It will ingest that KPIs into the PostgreSQL, which is a one-time activity. So it will perform all those steps. That's where it is taking time. So on the user interface, if you see now, it is still saying uploading the report, but yeah, in the backend, if you see, it is okay, uploaded the chunks. So now it should say it will start the extraction part. It's taking time because we have a huge files with us. And again, we have selected low parameters for the models like the token per minute and everything. So that's where it is slow. Okay, so you can see it has extracted these details out of this particular which file we imported, Tesla file, sorry, out of this Tesla file, it has imported these details. Now, if you see successfully save the matrices for Tesla 2024, and on the user interface, if you see success message, so that is done. Now, the moment it has completed, you can see the Tesla information is available. The revenue is $97K, then net income is again 7K. All that information is already populated. And you can see below now the Tesla is also available and you can see the top growth and risk factors for Tesla. And here also you can see in the company is available. That is, let's select Tesla and here you can ask the follow-up questions. Let's say what's the total revenue of Tesla in 2024. So whenever you are hitting this query, now it is hitting to the vector store, retrieving the content, and then it will deliver the response to us. So if you see, this is the total revenue, but for the year 2024, if you see, the revenue is 97K. So that's what we have mentioned here. This is the data for 2024K. So this particular chatbot is also working. So now we have covered all the parameters that we wanted to build as part of this particular application. Okay, so what else is pending now? So now you can go ahead and try it out. You can try uploading one more document. You can go to here and upload the new document for Microsoft and you will see the Microsoft information will start populating here. So I missed to showcase the data that is available in the Postgre. So if you see on the Postgre, it has ingested the data for Tesla and this is what it is used for serving the user interface. And if you go to the vector store, you will see the information related to AI search as well. So sorry, related to the Tesla as well. So if you again go to the AIS and go to the indexes, Now you can see the count has increased to 43. And here, if you search now Tesla, you should be able to see the Tesla information. So you can see Tesla is already available. And if you search Microsoft, it should not give any results because we have not ingested anything related to the Microsoft. So, okay, you can see zero results. So that's how this particular whole application is working. I hope this application was helpful for you. I hope you were able to connect the dots. I hope you were able to build the end-to-end flow out of this particular application. I hope you like the user interface. And if you have any questions, please feel free to drop them into the comment sections. Please go ahead and try it out this project. I would highly recommend create a free Azure subscription, create those services, all services that we have created as part of this video. Try it out, execute this code, just execute the code, clone the repository, add the environment configs and execute the code. And once you execute it, you can add these particular codes into the resume as well. But this is not the end of the series, guys. Now we are going to focus on deploying this particular application because whatever request I got, right, to cover the end-to-end RAG application. So in my mind, end-to-end is meaning we should cover the deployment as well. Currently, this particular application is serving on local. We need to host this particular application on some cloud server so that anyone can access this particular application. Obviously, I'll not be able to keep this application open for you guys to test, but in the deployment part, we will deploy it, we will test it, and maybe I'll have to take that application down in order to save the cost. Now this part is done, so what I will go ahead and do, I can go to the my this particular service, Azure AI service, and I can I can go to my Azure portal, and you should delete all these services. And the best way to delete these services is go to the resource group and delete the resource group itself. So we have created all the services beneath this resource group. So you should go ahead and delete the resource group. I'm going to delete it, and at the time of CI/CD, I will again create these services in order to save the cost, because these services, right, this part and the AI services, these charges us on monthly basis, right? So even though if you don't use these services, it will keep charging you. So better to delete this service for now, and that way it will not incur much cost. So just to show you the cost that I have obtained till now, so let me go to the cost analysis section and I'll show you the cost. Okay, so if you see, since yesterday I'm trying it out. So yesterday I gave the demo, I recorded the demonstration application, and then today I recorded this particular, we have done this coding part. So if you see, the cost is 335 rupees, and you can see the spike, sudden spike in the cost. So this is cost approximately per day we are getting, and you can see the distribution. Azure Cognitive Services are using 183, meaning the AI search. Then the OpenAI services that we are using, it is consuming 183 rupees. 144 is for this PostgreSQL server that we have used. You might be surprised that, okay, we have just ingested 3 rows, but it has calculated this much cost. And the Foundry models that we have deployed, it is the cost related to that. Okay, one mistake I made. So this is the cost related to the work that I have done yesterday, but same type of work I have done. Like I gave the demo, right? In the part 1 video, I gave the demo. So this is the cost related to that demo. So today's cost will also be reflected maybe by tomorrow, and it will be again around this same figure, close to 330 or 350 rupees per day. So if you are doing this activity every day, right, it will incur this much cost. So I would recommend go ahead and delete the resources. That's the reason I expect at least a like and subscribe from you guys. So yeah, that's it. So see you soon in the next video, where we will start working on the CI/CD. The tools and technologies that we'll be using, again we'll discuss it in the upcoming part. So please stay tuned for the next video. Till then, thank you so much. Please like the video, go ahead and subscribe to the channel and share it with your friends. Thank you so much, and see you soon in the next video. Thank you.